Hello everyone, I'm Vera from the University of Amsterdam, and I'm going to present our paper called Robustness Evaluation of Entity Disambiguation using prior probes, the case of entity overshadowing. And I promise that it's not as complicated as it sounds. Firstly, let's briefly talk about the task of entity linking. So at first, we have a piece of unstructured text, and we want to extract dimensions of named entities from this text. And a named entity can be a name of a person, of a place. Basically, if it has a Wikipedia page about it, then it's safe to assume that it is a named entity. So we extract dimensions and then we look them up in some knowledge base. Again, the Wikipedia is the most popular choice. And the results are so-called candidate entities. And we need to rank these candidate entities in a way that we choose just one of them for each mention because we want a precise answer. And this last step is called entity disambiguation. And this is what we focus on in this study. How does entity disambiguation usually work? Well, to rank the candidate entities, you can use two inputs. First of them is commonness, how likely we are to encounter this entity in general. And the second one is relatedness, how relevant this entity is for our particular document. A classic example, if you have a text that talks about graphs and we see a mention of a tree, then tree, the plant, is the most common answer, but tree, the data structure, is the most relevant one. There are some interesting edge cases of entity disambiguation. And we discovered one of them when we did some preliminary experiments before starting to work on this paper. We took a classic example of entity disambiguation, Michael Jordan, the scientist, versus Michael Jordan, the basketball player. We constructed two sentences and we gave them to three popular entity disambiguation systems, which have been shown to perform really well on some datasets. And we saw that even if we give enough context, even if we explicitly say that it is machine learning, like, come on, it cannot be a basketball player, the systems still choose to output the more popular entity, Michael Jordan, the basketball player. And it looks as if the more popular entity is casting some kind of shadow upon the less popular entity, and the models just simply not see it. And we decided that this phenomenon is quite interesting to study. We call this phenomenon entity overshadowing. And we came up with definitions. So one entity overshadows another if, first of all, they share the same surface form, the same ambiguous entity dimension, so they can be confused with each other. For example, if you just write Michael Jordan. And secondly, the first entity is more common than the second entity, and we think that we are more likely to encounter this more common entity. So as I mentioned, Michael Jordan, the basketball player, overshadows Michael Jordan, the scientist. And this phenomenon is different from another interesting case of entity disambiguation, which is called long-tail entities, because long-tail entities are uncommon, yet not necessarily ambiguous. And overshadowed entities can be relatively common, but still less common than other ones, and therefore they are still tricky for entity disambiguation models. So we want to measure the impact of entity overshadowing, but we see that the data sets that exist for evaluation of entity disambiguation are not quite sufficient for studying this phenomenon because they typically consist of news, tweets, books, things like that. And therefore, they mirror the same distributions that cause entity overshadowing. And it has been previously shown that if you simply learn the priors really well, so basically if you give the most popular answer, you have good chances to perform really well on the existing data sets. So we decided that creating a new dataset would be a good idea, and we created ShadowLink, a dataset designed specifically for the evaluation of entity overshadowing. So what is inside the new dataset? First of all, let's start with some basic concepts that we need. The first of them is entity space. This is a set of entities sharing the same entity mention. So the set of entities that can be confused with each other. And a good way to get these entity spaces is to look at Wikipedia disambiguation pages. For example, Odessa may refer to Odessa, the city in Ukraine, Odessa, the city in Texas, possibly some other things. And this is how we look at the entities that belong to the same entity space. Secondly, we need some score to measure commonness, because we need more common, less common entities. We need to know which is which. And we used a number of Wikipedia backlinks, which is safe to use in our case, because it has been previously shown that graph-based measures of commonness correlate with corpus-based measures. So the entities that have more backlinks are also more likely to be encountered in the web. And last but not the least, we need context examples, which is what we are going to give to the models for the evaluation. An obvious choice would be to simply take them from Wikipedia, take the sentence that contains the entity, but Wikipedia is frequently used as a training set for a lot of models, and we wanted to avoid any overlaps, so we decided to go and hunt for the examples in the wild by taking external references of a Wikipedia page and parsing these external web pages and looking for the examples there. The data set that we have has 4 different subsets. So there is a top subset, which contains the most popular entity from each entity space that we have. There is a shadow subset, which contains another one or more entities from the same space that are less popular. There is a neutral subset, which we need for our experiments with obtaining the prior predictions of the models. And the neutral subset consists of the names of our entity spaces placed in some neutral context. For example, I see Odessa. And they are not linked to any particular entity because the context on purpose doesn't give us any information about disambiguating this entity. And lastly, we have a control group at the tail subset. It is not linked to the same entity spaces that we have for the first 3 subsets, but it simply consists of unpopular entities sampled in a similar way. And we use them to compare entity overshadowing to long tail entities to figure out which is more challenging for the models. So we have 904 entity spaces, and we also have 904 tail entities to match them. And the commonness scores of the top entities are pretty high, and they are, of course, higher by design than the commonness scores of other subsets. And the tail entities were sampled in such a way that their commonness score is not higher than the threshold. So we want to use our dataset to answer 3 research questions. How well do the systems perform on overshadowed entities in general? How does it compare to the performance on long tail entities? And are the predictions of entity disambiguation systems biased, and how can we measure this? First, we did some benchmarking. We used Gerbil, the framework for evaluating entity linking and disambiguation. And we added also 2 modern systems, genre and rel. And we see that the shadow subset, this common one, is also the most challenging one. So it looks like overshadowing is indeed a problem. And we also see that on the tail entities, the systems perform quite well. So low commonness by itself is not a big problem. Higher ambiguity is in combination with low commonness is a bigger problem. And what was quite surprising to discover is that the best baseline on the shadow subset was developed 10 years ago, and still it outperforms the modern neural methods. So it is quite impressive to see. It makes us think that maybe the direction needs to change a bit for developing new systems if we want to take if we want to take overshadowed entities into account. And then we did the experiments with prior probes. So we put the names of entity spaces into a neutral context, which was designed specifically to not give us any information about how to disambiguate it. And we use this neutral context to obtain the prior answer of the model. So basically, if the model doesn't know anything about the context, it will give the answer based only on its priors, and this is what we want to obtain. And we had some meaningless sentences, for example, when nobody is around, which is gossip about Michael Jordan, Odessa, whatever we substitute into this template. And we used a majority vote across 7 such examples to obtain the prior answers of the models. And then we looked at 2 things. First, entity overshadowing itself, when the answer is the same for a top and shadow entity. And next, prior bias, when the answer is also the same for the prior answer of the model. And we see that overshadowing indeed looks like a problem, and a lot of wrong answers on the shadow subsets are caused by the system not changing its default prediction when seeing the context. And again, the system that performed the best on the shadow subset is also the best at adapting to context. So it tells us that it is important to pay more attention to context if we want to cover this case of entity disambiguation. So we introduce a new data set and we perform the evaluation of entity disambiguation using this data set. We show that for overshadowed entities, the task of entity disambiguation is still not solved. And our dataset can be used in the future research on this topic, and we hope to stimulate future research into the topic of overshadowed entities. Thank you for your attention. I will be happy to answer any questions.